And once again, this is the last section of Unit 2. I think it's the easiest section, especially if you already know all the previous sections. It's really easy. So again, these are your notes for this last section. Step 1 is to graph the function. You might have a line, y equals mx plus b. You may have a parabola, y equals a parentheses x minus h close parentheses squared plus k. You may have the absolute value function with the x minus h inside of the absolute value, the a out in the front, and the k being added or subtracted at the very end. So it depends what kind of graph you have, but before graphing it, whether it's a parabola or a line or a v, you have to decide if it's a solid or dotted graph based on the inequality. If you have a solid line underneath it, then it will be a solid graph. If you do not have a solid line underneath it, it's going to be a dotted graph. Pretty simple to understand. And in addition to graphing the parabola solid or dotted, or in addition to graphing the line, a solid line or a dotted line, you also need to shade either above or below your graph. So let's jump right in so you can see how this takes place here. We have this worksheet that you just got. Let's go to the very first question. It's on 2.8 WSP. Now the notes are right there. Now, is this a parabola? Is this a V, or is this a line? It's a line, right? It just has y and a number. So let's think of that line, y equals -3. What does y equals -3 look like? Even though it doesn't say equal, but what does y equal -3 look like? It's a horizontal line, right? Horizontal line crossing the y-axis at -3, but don't draw it yet, okay? We need to visualize. Here's the -3. We know we're drawing a horizontal line, but before we draw it, we got to do that first step. Is it solid or is it dotted? Solid, because it has a solid line underneath that inequality. So let's draw a solid line going right through that horizontal line, going right through the y-axis of -3. And now we need to shade. You either shade in above or below. What does the inequality say? It says less than, right? So you shade below, because below is less, above is greater. Now, this is true that below, less than, is below because you have y by itself. All of these functions, I shouldn't say all, the majority of these problems do have y is less than or y is greater than. So we do have y by itself, which means that you could think of it as the y values are either above if it's greater or below if it's less. So it's pretty logical. But when we go to number 2, some people may freak out, because number 2, x equals a number, is not horizontal, it's what? Vertical, right? Kind of like the axis of symmetry. So how do I graph this line x equals 2? Well, you would go to the x-axis, you'd go to 2, it'd be a vertical line, but before graphing it, is it a solid line or a dotted line? Dotted, because it does not have a solid line underneath the inequality. So this will be dotted, kind of like when we draw axis of symmetry, we usually do a dotted line. And now we need a shade. Now, even though the notes say if it's a greater than, it's above, if it's a less than, it's below, we don't have above and below here. That's only when you have y is greater than, then you would shade above, or y is less than, then you would shade below. This is x. There's not even a y involved in this inequality. So we can't look at it up and down in terms of y. We got to look at it in terms of x, which would be side to side. So which way is greater than? To the left or to the right? To the right. So let's shade in the right side. So we're definitely going to be graphing lines. We're going to be graphing absolute value inequalities. Let's look at number 9. Like I said, this last section is kind of like a review of all these different graphing methods that we've done. We've done parabolas, we've done absolute value functions, and we've done y equals mx plus b equations that are lines. So right here, how would we start graphing this absolute value function? Anybody? What's the very first thing you do? Vertex. That's right, vertex. What is a vertex? -1 and -2. Think opposite on h, take k for what it is. So let's graph -1, -2, put a dot right there. And normally on parabolas, we would draw an axis of symmetry. This is not a parabola, but we could still do an axis of symmetry because it does still help us reflect coordinates from one side to the other, even if it's a v instead of a u, if it's an absolute value instead of a parabola. So we could now move on to getting more coordinates, right? Now, if it were a parabola, if you had parentheses with the square, you would use a pattern 1, 1, 2, 4, 3, 9, but you have to modify it. But it's not a parabola. It's absolute value, which means that you could look at this and kind of look at it like slope from that vertex. So the a value is -3, which from the vertex, it kind of tells you to go down 3 over 1. So down 1, 2, 3 over 1. And we put a dot right there. And you could continue to go down 1, 2, 3 over 1 and put a dot right there. And with that axis of symmetry, you could just map them over to the other side. 1 unit away, 2 units away, and done. We have our graph. But before graphing, we have to ask ourselves, do we do a solid graph or a dotted graph? Dotted. So there are my dots. Again, this is not a parabola, so don't curve it. This is like a V. It's like two rays that share the same endpoint, which would be the vertex. And finally, we need a shade. Now, whenever you have like a V or a U, a parabola or an absolute value, we start thinking inside and outside, but that's not really the correct way to look at it. You either think above or below, and what would we be thinking of shading? Above or below? Above. Why above? Because this is a greater than symbol. So if you're thinking, well, what does that mean? I'm going to shade above. Put your pencil on any part of this V, put it on this blue dot. Where's above? It's up here, so shade in up here. Put that blue dot, it's shade in up here, because greater than is above. Greater than is above. So shade in everything except the V, yeah. So if you shade above, and you shade above, and you shade above, and you shade, if you go to all the coordinates and just shade above it, now keep in mind, it doesn't stop right here, because this does continue to go out and to the left forever, so you technically need to shade everything. Even going this way, down and to the right forever, so you need to shade in everything on the outside of that V. Whoops. What do you think?
Easy.
Pretty easy. All right. You know what? The inequalities could get interesting. I hope we remember the details. Like, well, we'll get to a parabola in a little bit, but right now let's look at this one right here. I like this one because there's so many little opportunities to make mistakes, right? Like, this is obviously not a parabola. It's not a V. It's not an absolute value function. This is just with x's and y's, no squares. So we need an equation in slope-intercept form to graph this line, right? You guys remember slope-intercept form?
Yeah.
Y equals mx plus b. And you know that the b value tells you where it crosses the y-axis, and then from that point you rise and run according to m. But you see, this guy over here doesn't have y by itself, so let's get y by itself. What do I do?
Y is greater than or equal to -2x.
Well, let's first subtract x. Let's start getting that y by itself. Subtract x. So what we have here, on the left side, we have a -3y. We have a less than or equal to. And the 6, take away x. You can't really do that, so let's just rewrite it. But I want to write it with the -x first and the +6 second. So -x first plus 6 second. Now we're almost done. All we have to do is this last step to get y by itself. What do I do? Divide by -3. Now, when we divide the x by -3, remember there's an invisible 1 in front of the x. So that's kind of like saying a -1 divided by a -3, which we'll get to in a little while. And also, don't forget to divide the 6 by -3. So what we have here is a final inequality that says y is, flip the symbol, just like you said. Whenever you divide or multiply by a negative on your last step, you have to flip the symbol. And a negative divided by a negative is a positive, so you have a positive 1/3 x. And the b value is a -2. 6 divided by -3 is -2. So
Can you flip the symbol again? I forgot.
we flip the symbol from here to here because on the last step, we divided by a negative. Anytime you multiply or divide by a negative, on the last step of an inequality, you have to flip the inequality symbol. That's the only difference between solving inequalities compared to solving equations. Anyway, we do go to the b value of -2. The y-axis, it crosses at -2 right there. And from that point, we look at our slope, which is up 1 over 1, 2, 3. And you put a dot right there. And of course, on inequalities, since we need a shade, you want to use the whole graph. So keep going up 1 and over 1, 2, 3. Keep going up 1 and over 1, 2, 3. You'll be off the graph, but at least you'll know where to point your line. And you could go backwards over 3, down 1, which you'll be off your graph in this direction. Anyway, before I draw my line, is it a solid line or a dotted line? Solid. Solid, okay. So here it is, solid line. Arrow there, arrow over there. Now we need a shade. Do I shade above or below? Above, right? Above, because this inequality right here is a greater than, and greater than is above. Put your pencil on any part of this line and just shade up. Obviously, going to be shading everything on this side above. So we've done lines, we've done absolute value functions. Oh, yeah. The answers are on Google Classroom, but what I want to do right now is go to these answers and let's work backwards, because this is very likely to happen on the test also. I give you the answer, the graph, and you want to come up with the actual inequality. So if you look at this graph, it's obviously not a parabola. It's obviously not an absolute value function. It's a line, right? And we need a couple of things to write the equation of a line and y equals mx plus b. We need the m and we need the b. So could somebody tell me any bit of information that would be useful? It crosses the y-axis at 3, so the b value is 3. Okay, so the b is 3, that's for sure. What about the slope? Positive 1/2, up 1 over 2. So both of you are correct. Up 1 over 2. As you look at it from left to right, you're going up 1 over 2, up 1 over 2. So yeah, the slope is 1/2. So let's write this inequality. Y, obviously it's not equals, it's an area. So am I going to write greater than, less than? It's going to be less than, right? Because it's shaded below. And I don't have a solid line, so I do not put a solid line. So that's the shading part. And now the m is 1/2. We have the x and plus b. That's plus the b value of 3. And voila, we worked backwards. We had the graph right here, and we came up with the inequality, which is a great skill for the test this Friday. Let's actually do some parabolas now. So flip the paper over, and you should see more practice, and we have everything right here. We have lines, we have absolute value functions, we have parabolas. Not only do we have parabolas, we have some that open up, some that open down. We have some that have an a value other than 1. Let's do this one. So how do I begin graphing any parabola? Vertex. All right, so what is a vertex?
1, 1.
Positive 1, right? Think opposite of that -1, take that +1 the way it is. Let's go to +1, there it is. Next thing to do would be to write your axis of symmetry right through that vertex, which in this case is the equation x equals 1. I'm not asking for it on this worksheet, but I'm just saying it to help you keep practicing that. Axis of symmetry is x equals 1. What else? We need some coordinates. Now this is a parabola. You see, you got curves right here, and we got a square, so we know it's going to be a curve, right? It's going to be a U-shaped curve. So we need some coordinates, and on parabolas, we usually use the pattern that we memorized, 1, 1, 2, 4, 3, 9. Now we need to modify it because that a value is 1. The pattern for this pattern is for the a value of 1, and we obviously have an a value of 1/2. So we need to multiply all the outputs by 1/2. So when I think of 1 times 1/2, I will get 1/2, which you could write as a decimal if you want, 0.5. 4 times 1/2, you'll get 2. 9 times half, what's half of 9? That's 4.5. So you could write decimals, you could write fractions, whatever you prefer. But the bottom line is this parabola does open up because it's a positive a value. And from the vertex, we will be going 1 to the side and halfway up, and then back to the vertex, 2 to the side and 2 up, and then back to the vertex, 3 to the side and 4.5 up. So that's what we're going to do. Let's go to the vertex. from the vertex, one to the side and only halfway up. We put a dot right there, halfway up. And then you go back to the vertex, and you go 2 to the side, and then 2 up. That's a nice coordinate right there. Then you go back to the vertex, and you go 3 to the side, and 4.5. Check this out. 1, 2, 3, 4, and only halfway off the graph. So I'm really close. Because I'm this close, I might as well actually draw it. Normally I say you don't have to draw a coordinate that's off the graph, but this is like really close, it's only halfway off. Let me map them over to the other side using that axis of symmetry. You're at that halfway point, that nice coordinate, and then we are off the graph just a little by half a unit. So here's our parabola. Before I actually graph it, is it going to be a solid parabola or dotted? Solid, that's right. It's solid because of the solid line underneath the inequality. And now I need to shade either above or below. Above, because greater than on y means above on the y. So go to any point, like this blue dot right there. Above would be, or greater than would be above. So shade in up here, which tells you you're going to shade in everything on the inside of this parabola. Above the vertex, above that dot, above that one, above that one. So you're really pretty much shading everything on the inside of the parabola. Now, if this would have been a less than or equal to, then you'd be shading everything below, which would be everything on the outside. And that's how to do it. It's pretty easy. Should we do another? I don't know. It's totally up to you guys. Anybody? No?
Yeah, number 3.
Number 3? Sure, why not? Number 3, we have another parabola. We're going to begin with the vertex. You know what? Before we even start, just for funsies here, reviewing transformations. Yeah? There's the parent graph y equals x squared. What transformations would that original parent graph y equals x squared go through to get to this new parabola?
Reflection over the x-axis.
Yep, this is a reflection over the x-axis, and then shifts where? One to the left
Down 1.
and down 1. There you go. Okay, so that's just, this is not part of the worksheet. This is just practice from yesterday's lesson of transformations. So yes, it reflects over the x-axis because of the negative sign. It doesn't get vertically stretched or compressed because you don't have a number right here. It's just -1, so you don't mention a vertical stretch or compression. This is a shift 1 to the left and 1 down. Anyway, back to the actual part of today's lesson. The vertex is what?
-1.
-1. You think opposite here, you take that one for what it is. Okay, yeah, so -1 is down here. Let's draw our axis of symmetry right through it. Obviously, we need more coordinates, so we will be using the pattern. The a value is -1, which means we can use the pattern 1, 1, 2, 4, 3, 9. Just remember that it is opening down, right? We don't have to modify the pattern. If I would have had a 2 right here, a -2, then yeah, you'd have to multiply that by 2, this by 2, that by 2. If I had a 1/2, I'd have to multiply 1 times half, 4 times half, and 9 times half. If you have any other a value other than 1, or -1 for that matter, you have to modify your pattern. If not, use the pattern, but it's opening down. So 1 over, 1 down, put a dot right there. Go back to the vertex, 2 over, 4 down, 1, 2, 3, 4, I'm right on the edge, put a dot right there. And obviously 3 over 9 down is not going to be there. So it'll be there, but it just won't be seen on this graph. This graph's not big enough. So just map it over to the other side. We have our parabola. Is this a solid parabola or a dotted parabola? Dotted. So let's put some dots. Put some dots. And then, you know what? I don't like black dots. I'm going to go for red dots. And then after that, we got to shade in either above or below. What do you guys say? Below. Now, what does that mean? That means the inside, right? Because if you pick any, like let's go to the vertex, where's below? It's down here. Any point below, any point less than would be over here. So yes, you're shading in the inside of the parabola. So ladies and gentlemen, this is the last section. It's a great review because it helps you practice graphing absolute value functions, graphing parabolas, and graphing y equals mx plus b lines. Let's practice some more with number 11. What kind of graph do we have on number 11? A line, a parabola or absolute value v? A parabola. What makes a U-shaped curve? The square, right? And yeah, the form is y equals a parentheses x minus h, and you don't see the parentheses. That just means that the h value is what? 0, right? And the k value is -4. So this is a parabola. So your vertex, like we said, h is 0, k value is -4. There's your vertex. There's your axis of symmetry. On parabolas, we have that pattern memorized, 1, 1, 2, 4, 3, 9. That comes from the original parent graph. But of course, we need to modify it because this a value of 3 causes a vertical stretch. So we need to modify the outputs by multiplying everything by 3, all the outputs by 3. So our new pattern will be 1, 3, 2, 12, and 3, 27. So that means that from your vertex, you're going to go 1 over and 3 up because the a value is positive. Then go back to the vertex, 2 over and 12 up. You're going to be off the graph already. So going 3 over and 27 up, there's no way that'll fit on this tiny graph. But let's go to the vertex, 1 over, 1, 2, 3 up. Put a dot right there. And let's say I did go back to the vertex and go 2 over 12 up. Check it out. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'd be up here somewhere, right? For funsies, I'm going to put a dot right up here. Now, notice that that dot is technically the x value of 2, right? So when I draw my parabola, let me reflect these coordinates over to the other side first. When I draw my parabola, I am not going to cross into my x value of 2. I'm not going to do that. That would be incorrect right there, okay? Don't do that. Do not cross into it. You know that it doesn't reach the x value of 2 until you're way up here off the graph. So you can't cross into 2. It has to still be on the left side of the x value of 2 if you want to draw it accurately. So keep going, up, 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 getting closer and closer and closer, but never actually crossing through it. And you're going to do the same for the other side. Closer and closer and closer, never actually crossing through it. And now we need to shade either the inside or the outside. What do you guys say? Inside, because the greater than means above. And if you go to any point on this parabola, like the vertex, greater than's above, so you'd shade in up here, which means you'd be shading in up here, up there, everything on the inside of the parabola. And of course, all the answers are there for you. You guys wanted to see 16 as well? All right. 16, what kind of graph is that?
Parabola.
That's another parabola. Why? Because it has a square on it. Anytime you have a square, it's going to be a U-shaped curve, a parabola. What's a vertex?
0, 3.
0 for h and 3 for k. Take it for what it is, right? So 0, 3 is up here. Is this going to be opening up or down?
Down.
It's going opening down because of the negative sign. We could draw our axis of symmetry, which is kind of not necessary because we already know it's the y-axis. But let's write out our pattern, 1, 1, 2, 4, 3, 9. And we need to modify it according to our new a value, which happens to be -1/4. So just multiply everything by 1/4. And if you use a calculator, when you multiply 1 times 1/4, you'll get 1/4, which is really 0.25, or technically half of a half, right? When you multiply 4 times 1/4, you'll get a 1. 9 times 1/4 with the calculator will be 2.25, which is really 2 1/4, okay? So this is your pattern, your new modified pattern from your vertex. 1 to the right and 0.25 down. Now, why do I say down? Because the a value is negative. Okay, and then you go back to the vertex, 2 to the side, 1 down, 3 to the side from your vertex, 2.25 down. So let's do that. We're going to go 1 to the side and only a quarter of the way down. That's half of the half. Not half, but half of the half only. So let's all put a dot right there. And then we're going to go back to the vertex and go 2 over 1 down. 2 over 1 down. And we're going to go back to the vertex and go 3 over 1, 2, 3, and 2 0.25. That's only a quarter of the way past 2 down. So that would be right there. Map them over to the other side. And you have your parabola. Is this going to be a solid parabola or a dotted parabola? Dotted. Okay, so let's put some dots here.
How would you describe that transformation?
Oh yeah, that's a great one to describe. Sure, why not? We'll do it right now. So the transformation, you begin with the negative sign. You would say reflection over the x-axis. The a value of 1/4, you would say it's a vertical compression, right? It makes it wider. It got compressed. It got flattened. So reflection over the x-axis, vertical compression by a factor of 1/4, and then the only shift is 3 up. So from your original parent graph, it gets first reflected over the x-axis, and then it gets vertically compressed, which makes it wider, and then it gets shifted 3 units up, which provides this wide graph opening down. Anyway, we still need a shade though. This symbol is a greater than symbol, which means I'm going to shade in where? Above, right? So let's shade in everything above, which is everything on the outside of your parabola. So I hope this helps, guys. Like I said, this is good practice, but it doesn't go into your homework grade. I'm not going to collect this. It's just practice for you. What will go into your homework grade is the practice test that's already available to you. So please make that a priority, doing that practice test. You have a couple of days to get the best grade possible. Good luck.